Hey brothers, how you doing? This is Coach Scott, and hey, we're with another edition of, well, guess what? Purple wave chemistry. So let's get into our first bit of stoichiometry by looking at this mole ratio. And I went over this in class, but well, this is about as good as any. So we'll look at this one. So let's look at the first one. All right. And remember what we're doing here. We're using the coefficients from a balanced equation, known facts, and we're using those as ratios, and that's what they are. They're really ratios, okay, of this much of this combines with this much of this to produce this much of that, okay? That's what we're doing here. And we can use a little logic to figure this out. So let's look at our first one here. So let's see, we've got lead. Now I looked at my periodic table already, and I see that that is Pb. So lead, Pb, will react with hydrochloric acid. Now I know that lead is a solid because it's a metal. So I'm going to put an S there. And hydrochloric acid is in water. It's mixed in water, so that's AQ. To produce lead 2 chloride. So I know what the charge of that lead is. It's +2, and chlorine is -1. So that means I need 2 chlorines to make this compound. So now I know what that formula is for lead chloride. Okay, I'm cool. So, and hydrogen gas. So hydrogen gas, of course, is have no fear, is always F2. That's gas. And lead 2 chloride, well, let's assume that that is aqueous in water. It may or may not be. Let's assume that. So let's get this balanced. I've got one lead, cool. Ooh, I got 2 hydrogens, so I'm going to put a 2. Let me use a different one. Let's go with that one there. So that means I've got 2 hydrogens now. I got 2 chlorines. Hey, I've got it balanced. So what does this mean? For every 1 mole of lead, I'm going to react or consume 2 moles of hydrochloric acid. I'm going to produce, for every 1 mole of lead, I'm going to produce 1 mole of lead chloride. I'm also going to produce 1 mole of hydrogen. For every 2 moles of hydrochloric acid, I'm going to consume 1 mole of lead. I'm also going to produce 1 mole of lead chloride and 1 mole of hydrogen gas. Those are our ratios. So our question here is how many moles of hydrochloric acid are needed to completely react with 4 moles of lead? So let's give ourselves, let's give ourselves, let's do a different color. Let's go with, that's a nice red. So let's give ourselves 4 moles of lead. And the only thing you could put in a BCA table are moles. Can't put grams, can't put liters, only moles. So I've got 4 moles of lead, and so we don't forget, I'm going to write moles. I don't know what I'm doing there. 4 moles. All right. So for every 1 mole of lead, I'm going to consume 2 moles of hydrochloric acid. So if I've got 4 moles of lead, is the moles of hydrochloric acid going to be greater or less? Well, they're going to be greater. So my ratio is going to be 1/2 or 2/1. Which of those ratios are going to produce or make more than 4 moles? Well, of course, it's 2/1. So I'm going to multiply by that ratio. 4 times 2, of course, is 8 moles. So this is before the reaction. I'm going to have 8 moles of hydrochloric acid. Now, before the reaction, am I going to have any products? No, I'm not. So I'm going to have 0. And I'm going to have 0 moles of hydrogen gas. So I'm going to make my change. I'm going to react 4 moles of lead with 8 moles of hydrochloric acid. Consume all of that. And I'm going to produce, let's see, for every 1 mole of lead, I'm going to produce 1 mole of lead chloride. All right, so that's going to be the same. So I'm just going to write 4 moles. That's what I'm going to produce. And how many moles of hydrogen gas? Of course, 4 moles, because that is a 1-to-1 ratio. 1 lead, 1 lead chloride. 1 lead, 1 hydrogen gas. 4 moles, 4 moles of lead chloride. So, of course, I have 0 left over, and I produce 4 moles each of lead chloride and hydrogen gas. All right, so that's the basics of a BCA table. All right, so after that, if I'm giving grams or liters, I'm going to convert that into moles, which I've got another video on how to go from grams to moles. And then if I'm looking for the mass of the products, then I'm going to go from moles to gram. And there's another video on using the molar ratio or the molar mass from the periodic table that goes over that. So look at that video also, and we'll be working on that as we move along in Unit 8. All right, guys, this is Coach Scott saying, Hullabaloo, Knick, and have a great day.